Okay, questions about example number 7. Makes sense? Do I need to leave it up a little bit longer? Only when you divide by a negative number. And so since, guys, Alexis asked a very good question. Both of these expressions right here, or equations, or inequalities, we divided by a positive version of the 3. Guys, listen. If for some reason this 3 had been negative, yes, you would have flipped the sign. But if it's positive, you keep it the same. Okay, go over to example 8. Now, 8 is a little different. We're gonna use all the same principles, guys. However, the last couple of examples, we were dealing with values that were less than. Here, this is our first example that says the absolute value of x must be greater than 1. In math terms, what this translates is that x must be more than 1 unit away from 0. So we're going to treat this just a little bit different. If we're thinking about a number line, and this is 0, what would we shade to represent something that's more than 1 unit away from 0? Okay, we're not going to shade 0 to 1 because that represents 1 unit away from 0. We want something more than 1 unit away from 0. So we're going to start at our 1 value and shade everything to that right all the way up to positive infinity. Now, just like with anything that we've seen so far, these are pretty much mirror images, right? So if we're looking at this in the negative direction, we want to shade everything from -1 and over. Okay? So this is where it starts to transition and change. You've got to look at the sign and what it's actually saying. Now, let's take this graph and write not only our interval notation, but what values of x we have. Okay, so if I wanted to write this left side of the portion in terms of x, what would I write as an inequality? X right here represents everything, what? Less than -1, right? And this portion of the graph represents everything as far as x is what? Greater than 1, right? Perfect. Now, looking at the graph, what kind of graph is this? Is it conjunction or disjunction? It's disjunctions. We have that or statement. So x represents values that are either less than -1 or greater than 1. Let's think about our original equation. Which one of these, the positive or negative version, matches the sign from our original absolute value equation? The positive one, right? So it's consistent to say that whether the sign is less than or greater than, that positive version, we don't flip the sign. When we set it equal to the negative version, that's when you flip the sign. So just make note, you're going to flip the sign when you have a negative number, or when you set it equal to a negative number. Okay, last but not least on this problem, I do want to write this in interval notation properly. So since this is a disjunction, it's a union, we're going to start at -infinity. We're going to go to -1. We're going to do the union in between because there's a break in my graph. +1, positive infinity. And so my final answer in interval notation would look like this. Okay? Very, very good. Okay, example 9. We're going to do these two. We're going to do this example, and then I'm going to have you do 10, 11, and 12 all on your own. So example 9, we introduce a numerical factor into the absolute value bars. So what we want to do is set this portion against 3 and negative 3. We know that the first positive value, we keep the sign the same. When we write our second inequality, we flip the sign and set it against the negative version. Other than that, it's the only thing that's different from solving from equations. Add 1 to each side. X is greater than 4. X is less than negative 2. We do want to graph these. Just pick 2 points. We're going to shade everything that's less than negative 2 and everything greater than 4. And then we want to write our final answer in interval notation. So if this is a disjunction, how do we write it in interval notation?
Negative infinity, negative 2, and then union, and then 4, infinity.
Perfect. Perfect, perfect. Like I said, that's the nice thing about this section, guys, is that it's either going to be a union or a conjunction, or a disjunction and a conjunction. You should basically see those 2 graphs. Now, like I said, we'll talk about special cases next class. But for right now, your homework, I mean, it's either going to be a graph that looks like this, or a graph where they're meeting in the middle. Okay? So what I want you to do is I want you to spend the next like 5-6 minutes going over example 10, 11, and 12. If you'll go ahead and look at 11 and 12, what do you need to do to both of these inequalities before you need to isolate the bars first, right? We need to get rid of that 4 by doing the opposite operation, and we need to get rid of the 2 by doing the opposite operation. So once you get to number 12, if you will, hold off, and then I will show you the answers to 10, 11, and 12.